morning, everybody. So everybody says that the Internet of Things is actually, well, not everybody, but Gartner says the Internet of Things is the peak of the hype. So hopefully in the next 15 minutes, we're going to talk about what we call the industrial Internet is. Usually GE and digital are not even spoken in the same sentence. But that's about to change, and it's going to change because of the industrial Internet. I'm not offending anybody, but hopefully, by saying that, IoT is almost like a teenage sex. Everybody's talking about that. Everybody thinks everybody else is doing it. Nobody knows what it is. So we're going to talk about what we believe is the real Internet of Things, or the Internet of really important things. Now, if I can make this clicker work. All right. So, in the last 20 years, the consumer Internet has permeated everything we do. And there is significant tons of devices, tons of storage, huge data centers that are managing all this data. And when you think about what they're doing, they're actually providing value for 5 billion or 3 billion people, 1.2 billion subscribers on Facebook, so on and so forth. So these companies actually are mighty, they're rich, they have a lot of capitalization. In fact, they're about 19% of the S&P total value. So that's a significant amount of firepower. And the Internet actually is changing everything we do, both as enterprise or consumers. But then you look at the Internet, or what we call the industrial Internet, and actually it's an order of magnitude more than what you would expect from the normal consumer Internet. So if you think about just aviation, and GE has about 6 businesses, aviation is one of them. If you think about aviation, every flight generates about 200 gigabytes of data in a flight. You have 100,000 flights, you have a day, you have 365 days a year. When you realize how much information there is, it's close to an exabyte of information just for the aviation side. Now, if you think about, it doesn't include only the engine, it includes airframe, cabin temperature, catering, everything around the aviation. But if you take it to every business, both businesses that GE is active in and businesses that GE doesn't even touch, agricultural technologies, shipping, logistics, and so on and so forth, then you get significant amount of sensors, significant amount of people that are using it, and significant amount of storage and compute power that you need to apply. Again, let's just look at the edge devices that we're talking about. Smart meters. There's 1 billion plus smart meters in the world that need to be read, need to be optimized, need to be analyzed in order to get the electricity and the water consumption optimized. We're talking about $100 million light bulbs, intelligent light bulbs, in 5 years. We're not even talking about autonomous cars, just internet-capable cars, cars that are driving with microprocessors and so on and so forth. We're talking about, way, way more than 100 million units. And so when you look at that, everywhere you go, from aviation to vending machines, you have millions of sensors that spit out data. And again, unlike Facebook users, they spit them out all the time, 24 hours a day, 365 days a year. So in order to make sure that we can actually deal with that, we have to build the capacity to analyze exabytes of information, and the industrial Internet is actually one of the things that today, at least, you don't see, but everybody is going to benefit from it. So let's look at the history of the Internet over the last 20 years. It starts in 1995, the original browsers. The first beneficiary of the Internet were the enterprise users. So this is where the Internet went in and changed menial work. If in the past, people were going with clipboards and writing down inventory on the shelf in a supermarket, you have ERP systems that allow you to get much more sophisticated and much more optimized. You could eliminate the menial work, the people that were doing it, not eliminate the people, but reassign them to other jobs, and you could get much more accurate reporting that allows you to just make better decisions. So that was for the first 10 years. At a certain point, there was always an idea that consumers are going to be beneficiary of the Internet, but it wasn't until the 2000s where these things actually took into overdrive. And this is where you completely change the business model. So instead of just doing things that you used to do only mechanized, you actually start creating new business model. What we know today as rideshare, what we know today as social networks, are things that did not exist before the internet. You had people writing faxes to each other, you had people writing sometimes emails, but it wasn't until the 2000s where we start seeing completely different models to deal with information. And this is where we connected people. So connectivity was really the most important things. We started in the last several years looking at operating things and putting them on the internet. All of a sudden, we'll look at the amount of data, we'll look at the complexity, and we'll look at who's going to benefit from that. And it completely changes the way that people can actually use and live their lives. When we're sitting here, we're depending on the power, we're depending on the air condition. There's a lot of expenses that go into that, and the question is, can we really optimize the operation of what we're doing in a way that will allow us to be at a completely different level in terms of the sophistication, and really at the level of awareness of how we use stuff and what we're using, and how do we make sure that the things is working all the time. The bane of the industrial ecosystem existence is what we call unplanned downtime. When you sit in a plane at the jetway and the captain comes and says, "Oh, we're not going to fly in the next hour," this is an unplanned downtime. If the airline knew what was going on before that, it would have been very easy. All you had to do, you wouldn't even know it. You'd get a different aircraft than the aircraft that we are sitting in. But if you're not prepared for that, this is where the costs start to ramp up. And so, in order to eliminate the downtime, in order to make sure that people are more informed, in order to get to the point where farmers know exactly how much moisture there is in the ground so they can optimize their harvest, in order to make sure that we know exactly what is the temperature in the containers in a container ship that moves from China to the US, all those things are things that we need the industrial internet for. There is a huge amount of value that is being built today. If you look at, usually we divide the ecosystem into a platform and application. So if you look at the consumer side, there's $170 billion in that. If you think about it, there is a bunch of systems, AWS, Alibaba is talking about cloud services, and then you have the applications on top of that. Apple is playing in both sides, Google is playing in both sides. There's a fair amount of value there. And then you go to the enterprise, there is even more value there, everything from expense report to HR operations. And then, again, you have the usual suspects. You have IBM, you have people like Workday that provide the application, Concur, SAP, etc. And then we're talking about the industrial internet. And the industrial internet is slightly different. And I'll try to explain why. At the end of the day, the industrial internet is dealing with different edge devices. This is no longer about smartphones and iPads and laptops that are used in the left two columns. It's completely different type of edge devices, turbines, locomotives, jet engine, and so on and so forth. At GE, we intend to play in both sides. So we're building what we call Predix, which is really the cloud-based operating system for the industrial internet. And then on top of that, we're building some of the killer apps for this business, asset performance management that allow us to really optimize the assets that we're dealing with. The assets that the industrial ecosystem is dealing with, unlike Fitbits, refrigerators, and everything else that you would assign as part of the IoT, is really a bunch of assets that need to work for 35 years, 40 years in the same environment, very harsh environments, very dirty, noisy, rotating machinery that has to work day in, day out, or we're not going to have power here. So if you think about that, this is actually what we believe is really the Internet of really important things. So let's dive a little bit deeper into that. As I said, most of the Internet devices or the ecosystem, the stack for the Internet, has really two sides. You have the cloud, even in the cloud, you have the cloud side, a bunch of boards sitting in a data center, and then you have the other side, which really the edge devices. But the edge devices, if you pop them open, they're laptops and smartphones, and they actually, from a operation point of view, they look exactly like the boards on the other side of the spectrum. So if you take a board from the data center, you take a machine from people's hands, they pretty much the same thing. You know, there is a processor, there is a set of storage, and you try a memory, and you try to optimize the operation in such a way that you're not limited by the size or the thinness of those edge devices. In our platform, it's completely different because the edge devices don't even look like computers. They look like everything else. And so in order to make sure that we can connect to them, we have to make sure that we have to build a different stack. And so between the edge devices and the cloud, we're building a bunch of useful gateways or useful levels that will allow us to actually make the whole thing work. So we talked about the edge devices. We're talking about the boundary of the cloud. If you're working in a wind farm and you have multiple turbines that you want to optimize the operation for, you have to make sure that the information is gathered, cleaned, normalized, and then being ingested by the cloud. And the reason is that, again, unlike the normal, quote-unquote, internet, the consumer and the enterprise internet, the data doesn't always make sense. When you pick up all kinds of temperature reading and pressure readings that may be spurious. So you have to make sure that you clean the data before you ingest it to allow you to create analytics and a way to analyze the information that is much more in line with the data that you really need to get. And then you go into the cloud. We made a decision to go and really focus on things that only GE knows what to do, which is actually the ability to understand how these devices are built. We manufacture those devices. Other people in our ecosystem manufacture their own devices. And we want to make sure that we take all these bases of knowledge and we combine them. So we know how the manufacturing is done. We have all the data from the actual devices in operation. And then we have all kinds of other data, public data, that allow us to create a very good model for how those devices are going to keep working. So think about a jet engine. We know exactly how each one of the blades and the composite material was manufactured when we did manufacture that. We know what is the pressure, the temperature, the rotating speed of the engine in flight. And we also have data about whether the air is clean, how much wind there is. And so we can advise the pilots and the operator during flight how the engine, the jet engine is going to, or the jet in general, the plane is going to perform. And if we find that there is actually a decline in performance, we will stop the redeployment of the same asset in another flight, and we'll suggest that other planes have to be brought in to actually continue the operation. So when you think about that, it's a completely different way to analyze the data than the way to do it today. Most of the industrial companies are acting based on schedule. They're going to service an engine every 100 hours. But at the same time, you can go to the machine and ask the machine exactly how it feels. And if it doesn't feel well, this is the time to service that. Actually, the right time to service that will be before it doesn't feel well. But all that information is going to be driven by the device itself, not by some schedule. If you fly above North America, it's one thing. It's clean air. It's great. You can maybe service every 100 hours. You fly over the Middle East. You fly over China. The air is more polluted. The blades get worn out. And then you need to change that. The same thing in transportation. The same thing in oil and gas and power and water. So we want to make sure that we can get those assets optimized. As I said, we built Predix as an operating system, an open operating system to allow us to deal with this information or allow other people that provide value to deal with this information in an easy way. So the developer of optimization software for seed management or for agricultural technology or for how combine work don't have to think about the stack from the ground up. And the way we do that is that we created a system that first has amazing scale. It can manage zettabytes of information without degradation. It allows us to do faster innovation. We created the basic services within the stack so other developers will not have to worry about how do I adjust the information at a maximum speed? How do I make sure the information is authentic? How do I make sure that nobody touched my information? A lot of our installation and devices are considered critical infrastructure by the states, the federal governments, and so on and so forth. So we want to make sure that security is actually at the top-notch level. And in fact, in many cases, we go beyond the regulation of the US federal government because we believe at the end of the day, this is not about satisfying requirement or regulation. It's making sure that nobody knows how the United Airlines jets operate except for the United Airlines authorized personnel. Because we're dealing, as I said, with the in the spectrum between the edge and the cloud, we want to make sure that in any given point, there's not going to be a soft weakness or where people can go in and either basically masquerade as the authentic user or create rogue information. And that's something, and then at the end of the day, we have to make sure that the analytics is such that will allow us to create new technologies to make sure that we can analyze the devices and the operator rules in a much more sophisticated way. As I said, it's an open innovation. We work globally. GE is a global company, so we work with everybody from China Telecom, a bunch of carriers in the Middle East. We're working with companies that are not buying anything from GE except for the software. Pitney Bowes is a good example, and there's a bunch of others that we're going to release. And then we're working with small companies that are building those pieces of software on top of Predix. Once you build the software on top of Predix, you can go and deploy it anywhere you want, and you can follow the machine from everywhere from Saudi Arabia all the way to China, because Predix has presence in all these territories, and actually the Predix system makes sure that the applications are deployed at the right place. So I hope I gave you a quick tour as the scenic route of what we think about the industrial internet. We think it's only the beginning, and we need a lot of help to make it work. We build this thing in a way that there are more holes than cheese, and we are looking forward to working with a bunch of industries, a bunch of companies to close those holes to make sure that we create a system, a much better system for tomorrow's needs and uses. Thank you very much.